Thank you. I'm going to switch gears for a moment and speak with you a little bit about security for online transactions, but not in the boring, annoying, get out of my office sort of way that the FFIEC talks to you about it. I'm going to speak to you about it in a more engaging and next generation sort of way that's actually easier on your users and more secure at the same time, something you've probably always thought of as a trade-off. We're going to show you a technology that's actually live in production at Charles Schwab Retirement Technologies, and they lease their online platform to 80 other financial institutions, so it does pass muster. The system I'm going to show you is actually a multi-factor login that eliminates passwords and yet is more secure against the prevalent forms of hacking. It's time to start asking what comes after passwords, and this is one of the answers. Let's take a look. I'm going to log on quickly and briefly without even explaining at first what I'm doing, so you can get sort of an idea and see approximately the amount of thought and time that it takes. I just did a successful login, and you probably don't even know what I did. So let's do it again a little bit slower, and I'll explain it for you. When using this system, when the user enters a username, instead of being asked for a password, they see an array of images that's different every time you log on. But you know what to look for because the images, which are different, are based on categories that are the same. Okay, in the example here, the categories are flowers, cats, dogs, money, airplanes, and so on. When I chose my username, I chose some categories that I could remember, and every time I log on, that's what I'm looking for. I'm interested in airplanes and dogs, and so those are my categories. All I have to do is recognize the dog and the airplane, and they give me a one-time access code just for this login. In this case, it's IX, and when I enter that in the space provided, I've got a successful login. Now let's talk about security for a second. I'm going to log in a second time, and you'll see three changes take place. First, the image categories shift positions, and second, the image inside the category has also changed. Those two factors combine to mean that you're going to need human-level cognition in order to recognize the system. So software cannot map and recognize this and try to figure out the answer. In addition, the digits have changed as well. So even if I should get malicious keylogging malware on my system, it doesn't matter because any keystrokes that the hacker captures are going to be useless in the future. Now, the user doesn't have to know or understand any of that. All they have to do is recognize a couple of categories that they have chosen because they're interested in them. Now, you can see from the display that we've actually, in making it easier on the user, made the guessing space smaller. And we have a cure for that as well. We actually withhold the display from unauthorized computers. The system is working right now because it sees a soft token on my hard drive, and if it didn't see the soft token in place, it wouldn't show me the images at all. So if someone were to steal my username, they would never even get to the guessing space. And if you'll come see us at the display, I'll show you the process. It's an out-of-band process for getting the soft token in place, and on future logins from known computers, then you go straight to the more secure image-based login. Now, the system is effective against phishing for a couple of reasons. First of all, we have way more than the 9 categories shown here, and in fact, the system is highly configurable so that you can change the size of the display, you can change the number of categories that the user is required to choose and enter, you can require them to be in order or not, and so forth. But because we have way more than the categories shown, if you're drawn to a phishing site, the phisher is unlikely to even be able to display the correct images for you in order to fool you into giving away your shared secret. In other words, you're going to be looking for a cat, and there's not even going to be a cat present. So it'll be impossible for you to give your secret away. Even if they do succeed in stealing your image secrets, they won't be able to reuse the stolen secret because when they take it to another machine, they're not going to have your soft token in place and they're not going to be able to get it. So they will never even get to the guessing space. Also effective against keylogging malware, as I said before, because the image codes change with every login. The system is, again, live in production at Charles Schwab Retirement Technologies and is being distributed to 80 other financial institutions, passes muster for the FFIEC requirement on multi-factor logins, and yet is easier on the user in the long run because it's based on properties of the human brain that are shown to be both easier and more reliable. Those properties are recognition instead of recall, and the picture superiority effect, which shows that the human brain processes visual imagery easier and more reliably than text. So once the user gets past the fact that it's simply different, there's 60 years worth of research that shows that it is actually easier on the user. And that's also borne out in user studies and the data that we can provide. So if you'd like to have more information on a more secure login that protects your users against phishing and keylogging malware, as well as brute force and some man-in-the-middle attacks, come see it at the display, and we'll be happy to go in a little bit deeper, drill down into some of the other security properties. Thank you.